Hello and welcome back. Today we have another Q&A. I think it is number 6. And here I answer some questions that people have put in the comments and that I could not answer immediately, or just people have sent me their projects and like them to share it. So yeah, I have a few again. So first I like to show you what is coming. So I have here this rider, and I show you last time. I'm still waiting for the power supply, so that's going to take a little bit more time. Um, about my last video, that was about this Unity signal generator. I tried to build external reference, so it all looks like it is, but I didn't. Yeah, I didn't succeed, and I got some great responses and great tips and good advice. So I'm gonna try this also soon. And apparently, I didn't take a good ground point. At least I didn't check if it was a good ground point. I just took it from the USB. And yeah, some people also told me probably the USB ground. It was just easy accessible. But usually it's not grounded because then you can get a loop with all your other devices. So that is a good one to try. So I will also do that later. Also add something silly, just these are power plugs, and you can connect them to your Wi-Fi and probably with an app in your phone, you can switch the lights on and off. And I like this one because it was very small and very cheap. And I can just put them in my lights there because sometimes I want to be in the dark to have a better look at the spectrum analyzer or at just at the screens of my devices. And then it's easier for me to just switch it off from here instead because my switch is downstairs. So, or I just pull the plug here. That's what I usually do. But let's pull a remote plug. So I'm gonna try that later and install the app and try to do with the screen recorder. But that's also not today. It's also for later. And this device, this was my first video, and it is an RF tester. It's like the cheap little, well, it's not necessarily very cheap. It is a radio test set, so it's like my Marconi. It can do a little bit less. And but it broke already before I was able to put it on film. And Banggood sent me a new one. So, and they packaged it a little bit better. So we're gonna really try, and you guys also ask me questions about that, even though I didn't even have the proper video about it. So now we're gonna play with that. So that will also be coming. And I think it was Leo, if you remember correct. He said, I have this field tech and I built external reference just like you. And it has a frequency counter, but the frequency counter only goes up to 100 megahertz, if I'm correct. So he said, what if we put the prescaler in front and I can go a lot higher. So I think we both ordered the same. I hope he also has it. So I'm gonna try it, but it's I couldn't find a proper division. So this one is 64 or 128 or 265. So it's not. It would have been nicer if you can divide by 100 or 1,000. But we're gonna play with it anyway. It was not that expensive. Yeah, in one of my other videos, I had this little portable oscilloscope. I think it was the C1 118. And now I found another one in the same series. It is the C193. And this is going to be a nice project because we are going to see a huge, huge difference because this is what it looks like. So that would be cool after it's cleaned, and then we're going to see if it still works. And well, if it's the same quality as the little one, as the 118, then yeah, it absolutely is working because that one worked sublime, sublime. So that's cool. And I also found a proper decade resistor, and it is from General Radio Company from the US. And it is kind of old, so in that video we're gonna see exactly from what year it is, or at least do a good guesstimation. And yeah, I also had people sharing their projects. That is also nice. So I'm just collected them that people sent me, and that is from over the year because I have not done this before. And yeah, I like if people do that, and as long as I can still collect it and put it in a video, I will. So this was John. He has the same frequency counter as I have. It is very nice. This is the TTI TF930. Goes up to 3 gigahertz. There is only one little thing. Well, the the external reference is in the front. And John didn't like that. So John sent me pictures, and I will show you also how he put the BNC on the back because it's a metal plate, so it's very easy to do. And then it's also it looks a lot better on the bench instead of having this cable always in the front going to your external reference. So I like the idea. So thank you, John, for that. And I will show you the pictures. And yeah, I have several marks subscribed on my channel. And this is the Mark from the Netherlands, and he has a very nice collection of old multimeters and Philips test equipment. And he sent me these pictures. And other people send me, but I think I mentioned before, it is really cool that you guys sometimes just send me manuals when I'm asking for it or send me extra information, and then I'm always sharing that also in the description of the video. So that is really cool. And yeah, Willem, Victor, Mark, Lucas, they all contributed to this information. So that was really cool. And there was an Leo, another Leo from the Netherlands this time. He converted this Skyline CB base station. He converted it into a BitX40. That's a 40 meters SSB transceiver, and it looked cool. So I will show you a picture of that. And another Mark sent me. That is really nice. Mark has been with me on the channel for a long time, and he knows also everyone is struggling with the same. If you buy all test equipment like your HP or the Fluke, if you have the big ones, usually the feeds are missing. So he sent me some links from a Thingiverse, and I think he even also designed one himself. So thank you very much for that, Mark. And then I have two questions left. That is from Kai. Kai, I think from Germany. Uh, he he also had this EEPROM programmer, and he had some troubles that his voltages were not good, and he asked me to measure. Well, I did not have too much time this week, so I will do this now. But I think he already found out that it was not good, and he sent it back. But thank you anyway, Kai, and I will try just to so that you are sure. And I have from Japan. So I think I put it through the Google Translate, and it should be Natsu Noto. So thank you, Natsu, or Noto-san, for your question. It was an older video from the Saturn 40, and he said, "Can you measure on the microphone because my microphone doesn't work, and I think something in my connector is not good, or I didn't wire it correctly." So I will do that. It is yeah, instead of the 4-pin, it is like a 5-pin. It looks like an yeah. I think in old stereos you had exactly this one, so it's a bit of a strange connector, at least different than we use now because now we usually use the big 4-pin. So let's see if we can find out a little bit more about that connection. So Kai, you told me that your VCC was a bit low, between 2 volts, between 2 and 4 volts. Uh, I have trouble measuring that, to be honest, because it's only putting power during the read, and the read is in 93 milliseconds, so it's really, really fast. So first I had the normal setting on my digital meters and they see nothing. Now I switched off the, this is the only thing that works now on my Keathley, because the Keathley is super fast, but I need to switch off the auto ranging. My Owen doesn't see anything. It is super, super slow. And even if I make it faster, switch off the auto ranging, it just says, oh yeah, maybe half a volt. Even if I put the MUD options with the min max, nothing. So I thought, okay, go back to my Keathley. I can try the same. Auto mode off. So it's now in the 20 volt range, otherwise it would be in the 2 volts. And then I sometimes can see, but mine goes up to 4.7, 4.8. I thought, yeah, that's because it's digital. So I try one of my analog meters. Now it only moves a little bit. Then I thought, wait, I have my cool millivolt meter. It is quite fast, but not that fast. And also, of course, it needs to lift the needle. So just, yeah, that also didn't work. So it is faster, but not that fast. So, and the probe on the oscilloscope, then it immediately gives a pin fail on the programmer, so then it stops. So what I did now, I will show you. So keep an eye on the meter. And I will do a few reads, and then hopefully you can see that it actually goes to 4.7. You saw 4.7 and 4.8. So my voltage is indeed a little bit higher than yours. So yes, and of course I had a problem programming it because the voltage is just too low. So that is a fact. So that was fast, super fast, but I did see 4.8 and 4.7. And so that is higher than yours. So I think yours indeed has a problem. Or your meter is also just, I don't know how you were able to measure that. For me, this works best because with the oscilloscope, I thought that's nice because maybe I can try to store it. Also, that I didn't find out, but and Apron programmer already failed when doing so. So I didn't do that. Programming, of course, fails because it needs 21 or 25 volts, and this new one only put 18 volts. But I have seen already from other people that they just feed in external 21 volts or more on the program pin, and then programming works. So I hope that helped. Oh, and I saw there is an upgrade available, so I will show also how you can do an upgrade. Well, this is maybe also a great moment to see how you need to upgrade. And I see here a message, upgrade available. So if we go to help online, it opens the page. Here you go to the software you need. That will then open another page. And here you can do your local server. Now probably they can detect where I'm from, and then you download. That will take a while because their download site is not that fast. I go here to my download folder, and I should have, if I go to modify, here is my new version. I will extract. Yeah, that is okay. Extract it. Okay, close this one first. Updated the driver. Okay. Now it would be cool to see the upgrade process. So hopefully it is still the same. Yes. It is indeed 10.90. Then we go to tools and you say refirm. here we go. Yeah, why not? Succeeded. So now we have updated the firmware from the EEPROM programmer. Cool, that was easy. So that's it. We also find out the mic. So I hope that helps. Yeah, that's it. Thank you for watching, and I hope to see you next time.